And then we move on to two speakers, two young guys from the solar team Eindhoven, which I don't need to introduce because they brought their own introduction.
Yes, thanks, Jörg.
In 2012, a group of ambitious students from Eindhoven University of Technology embarked on a groundbreaking journey. Their mission? To revolutionize the automotive world with a solar-powered family car. But to take part in races, it needed to be fully licensed to drive on regular roads. Over the last 9 years, Solar Team Eindhoven cars have been crowned world champions 4 times in a row during the renowned World Solar Challenge race across Australia. Every 2 years, a new student team takes the helm, each adding their own piece of innovation to this solar legacy. The cars are becoming more efficient, more practical, and more aligned to the needs of a modern family. In 2021, the team once again made global headlines by constructing a solar-powered camper van and journeying to the southernmost tip of Europe. Now in November 2023, Solar Team Eindhoven has come to Japan to share what's new in its most daring project yet, Stellar Terra. This isn't just a family car, it's an off-road vehicle, ready to take sustainable mobility to new rural terrains. So here's the story from team members Nick Boxerbelt and Niels van den Broek.
So yes, hello everyone. First of all, we're very honored to be here, to be speaking to all of you. Let me also introduce who we are. I'm Nick. I'm the system architect of both electronics and software engineering of the last Solar Team Eindhoven. And with me is Niels, who was photovoltaics and drivetrain engineer. And I will also introduce Solar Team Eindhoven. Solar Team Eindhoven is a student team, which means that around 20 to 25 students from the Eindhoven University of Technology start every 2 years on their own project. These students stop their studies for about 1.5 years and fully dedicate their life to producing something in the future of solar mobility. We get no financial compensation. These students do that because they foresee a greener future and want to show the world what's possible. With this, last year, Niels and I built Stellar Terra. It's an off-road car that shows how you can make an adventure on solar energy. Because solar energy should not pose a boundary, it can give an opportunity. Solar energy is everywhere, whilst even petrol stations are not everywhere. So with a car, a solar off-road car, you can get to places where we have not been before.
Yes, let's introduce Stellar Terra, the first off-road vehicle that's completely powered by the sun. It only weighs about 1,200 kilograms, and with its battery capacity of 50 kilowatt hours, it has a range of 710 kilometers. Its secret, its aerodynamic and lightweight design, while using cutting-edge technologies like in-wheel motors or the integrated solar panels, which are placed on the bonnet and the roof of our car. Also, the MPPT that we designed ourselves is highly efficient to make sure that every joule that we catch from the sun is as efficient as possible converted. And moreover, this is not a stationary concept, it's a real driving car with a top speed of 145 kilometers an hour.
And what's more, this car can even drive on public roads. It has passed full homologation, which means that it's not just a concept car, it's an actual leap into the future.
Yes, and the homologation was an important task for us, because last October we went to Morocco, where we drove about 1,000 kilometers on the road, but also off the road. We drove about diverse landscapes to really challenge the car and test what is possible with it. We drove up to heights of 2,100 meters. We drove at slopes of 40% and ended in the real Sahara Desert on the sand dunes. Our journey started in Tangier, and about 1,000 kilometers to the south, we ended in Mesuga.
And with this journey, showing that Stellar Terra can make these more than 1,000 kilometers, we think we have definitely shown that mobility and even off-road mobility on solar energy is possible today. And why did we do that then? We think that currently 20% of our global CO2 emissions are from mobility, and we think that number can be reduced. At the moment, the current state of technology allows us to make vehicles much more efficiently by really building the vehicle around efficiency and around solar energy. So by making these innovative concept cars, we want to accelerate both companies around us, but also individuals everywhere to see what opportunities there are in the world of solar cars.
Yes, and what we really want to show with our concept, with Stella Terra, is the independence that you can get from the sun. Because as Nick said, 90% of the global CO2 emissions is from mobility. And by using electric cars, you can decrease that number. But also electric cars have some big disadvantages, like they need big batteries and also they need to be charged. And the more and more electric cars are getting in the world, also the electricity grid is more and more tired. Not only in parts of the Netherlands, but also in Texas, America. Moreover, there are quite some countries in the world, especially in South America and Africa, where there is no very well developed grid. So it's not possible there to get a lot of electric vehicles. So by going for solar integration on the cars, you can not only put less pressure on the electricity grids, but also in countries with less developed electricity grids, you can make the electric cars more feasible.
Yes. And this is not the first time we're building a solar car. Solar Team Eindhoven has had 6 teams now, and it all started in 2012, when there was a team of students who thought, okay, there have been single-person solar vehicles developed, but when we look around us, no car on the street, also not in Tokyo, is a one-person car. We need to show the world that a family car is also possible in solar energy. And that's when they built Stella. What they did with that is they raced in the Bridgestone World Solar Challenge, a race of universities of more than 3,000 kilometers through the desert. And then they won that race. They became champion. And the subsequent teams, 3 teams after that, also became world champion in this university race.
So, as Nick said, this team, the solar team, already exists for 10 years. And we had 6 teams, and every team contributed to the more and more knowledge that we get how to build a solar car, and especially how to build aerodynamic and lightweight cars. So now we're going to emphasize some expertise that we get in different fields.
Stella Terra is designed on the Eindhoven University of Technology campus and built locally together with industry partners. For example, advanced design is achieved using special digital twinning software from Siemens, drastically reducing the development time and cost.
So here you have the battery management system controller. Yeah. So its main purpose is to get sensor input from different components in our car, but mainly from the battery package. And then it determines from the sensor input if the battery is safe to operate or not.
Many of the converters that are found for high voltage to low voltage conversion are in the several kilograms range, so like 5 to 10 even. Yeah. And the one we made is less than a kilogram. Yeah. We can shut parts of it off to achieve a higher efficiency, because if converters are running with little load, they are very inefficient. So that's why we can turn maybe 1/3 of it on if the LV power consumption is low, and when power consumption rises, we can turn more and more modules on.
Also, the sound of the car horn is really interesting.
Okay.
The tone, the frequency of the horn is different as other cars, because usually they are using two frequencies. Two frequencies that they mix up into one that is more regular. But we only use one car horn to reduce the weight of the car.
So, amongst this, we will also show 4 technological expertises that we have developed throughout the years. And the first one of this is composite manufacturing. This was mainly used in our projects for the outer part of the solar car, as this part needs to serve 2 purposes. First of all, you need a very stiff and structurally sound exterior of the car. But secondly, we also need a very aerodynamic hull, as when you're traveling quickly, the main losses in a car are from aerodynamic drag. We have, throughout the years, done this by building carbon monocoques and glass fiber shells around our vehicles, and we have a lot of experience in building these. In processes like mold design, mold making, but also lamination and even baking of the products ourselves. We all did those in-house.
Yes. So the outer shell has a major part in our vehicle. The outer shell is designed as in a collaboration between different divisions in our group. Not only the design is important, also its aerodynamic performance and the way the solar panels are integrated on the outer shell. So it's not only about cutting aerodynamically through the air, it's also how you place the solar cells on the car such that you gain as much energy from the sun as possible. During the design, we had many iterations, such that every iteration we tried and we looked through the computational fluid dynamics based design. How can we make this car even more aerodynamic while still guaranteeing that it's a good looking car and that the solar panels integrate easily on the car? And this resulted in a drag coefficient of only 0.21 for our car, which is less than half for comparable off-road vehicles like a Jeep Wrangler. And let's name another example. In the right corner, you can see a solar camper van, which our previous team made. That car has only a drag coefficient of 0.15, which is about 3 to 4 times lower than conventional camper vans which are on the road. So by the synergy of form and function of our outer shell, we're making sure that we have an aerodynamic car while the solar panels are integrated on an efficient way, such that we really can drive our car and also an off-roader on solar power.
And then on to weight optimization and simulation. Because the second pillar for efficiency is to have the lightest possible car, especially when going off-road. As you can imagine, when you would cycle, for instance, in loose sand, that's very tough, which is why we wanted to make our car as light as possible, because if you would have somebody extra on the same bike in the sand, it would be even tougher. How we did this is using digital twins. We did a digital design next to our physical vehicle, and in that design we used techniques like topology optimization to come up with the basic structure of a part, and then also we did FEM analysis and shaped the parts differently to in the end up with a manufacturable part that is also as heavy as it should be. Because through iterations of FEM simulations you can shave off weight in the parts you do not need it, and then in the end full designs like our suspension, we can guarantee both that they are stiff and sturdy enough, but also that they're as light as possible.
Yes, and a solar-powered car, of course, does not drive without any electronics. The major task of our electrical team was by designing the electrical architecture. For this, we used the zonal EC architecture, which promises a efficient data and power flow through our car by minimizing the amount of cables that we use, which reduce the cable mass in our car. Besides, most of the PCBs we designed ourselves, from the battery management system controller to the drivetrain controller, auxiliary controls, and even MPPT. This gives us ultimate freedom to design a system which met our requirements. So we made a system which is can easily be integrated in the car, which is lightweight and also as low power losses as possible. For example, our high voltage to low voltage PCB, we designed most of the parts by ourselves. We used 3 different buck converters, which we can switch on or off dependent on the power consumption. That to ensure that the power losses of that system is as low as possible. So the way that we looked in the design of our electric system is not only to make it as easy integratable as possible, but we also looked at how we can keep the losses as low as possible, such that we can drive as far as possible on the power of the sun.
And then onto solar integration. We'll go into this topic a bit more deeply. As we say, there are 2 things you can do. You can add a solar panel on a car, but we did is the opposite. We build a car around solar energy. And here it's very important what you do with the placement of your solar cells. By carefully looking at that, we managed on the solar area of Stella Terra to reach 6.8 square meters. But we also thought, if you're an adventurer traveling with this vehicle to a far place, you will also need shade and other things. So that's why we added expandable panels, which can expand your total surface area to 15.5 square meters and also give you shelter around the car. We did this using relatively standard monocrystalline silicon cells to showcase that even on these relatively cheap cells, you can drive hundreds of kilometers, and in fact we can reach a peak power output of 3.5 kilowatts.
Yes, and it's not only about the surface of the solar panels, it's also how you place it. The group efficiency is important. What is the group efficiency? First, let's explain how we build our solar deck. So you can see the solar panel as individual cells, which are separated in groups. And you can see in the colors on the right corner. Each cell is connected in a series to form a solar group, but the way because it's a series, it's like a chain. The weakest chain determines how powerful the solar deck is. So if you just randomly place the solar cells with a different direction to the sun, and if the sun is standing, for example, towards this solar cell, then that cell gains a lot more solar energy than this cell. But as this links in a chain, this solar cell determines the amount of current that flows through our solar deck. So that's why we spend a lot of time into optimizing the solar deck with MATLAB to get a grouping efficiency of 95%, which means that in average, the solar cells in each solar group has the same direction to the sun up to 95%. And here you can see a video of our partner Mito Solar, which made our solar deck by their innovative way, which they came up with.
Mito Solar is a startup company, and we are specialized in the development and production of custom solar modules. And they're often lightweight and intended to put on various surfaces like vehicles or ships.
Innovations we use within Mito Solar are, for example, the microstructure that is used for solar car racing applications or solar boat racing.
Doing research, we found out that having a microstructure on top of our solar modules can increase the optical performance. So this means that more light is captured within the solar module, increasing the efficiency. And this also makes that the module is more independent towards the angle of the sun. So the unique thing about our solar modules is that we're able to make them in various sizes, shapes, thicknesses and also materials. And this means it's really easy to integrate them on the surface of your vehicle or boat. Also, we are producing the modules in the Netherlands, and we have a really strong emphasis on the quality of our modules and the efficiency.
I see a future where large vehicles are utilizing solar arrays to be self-sustainable in an environment where utilities are limited.
Yes, not only by placing solar panels on a car you can make a solar vehicle, you also need a device which is called an MPPT, which is standing for a maximum power point tracker. Its main purpose is boosting the voltages of our solar panels for solar groups, because the voltage out of our solar groups is lower than the battery voltage. So it needs to be boosted to our battery voltage such that we can charge and drive our vehicle on solar power. Besides boosting these voltages out of the solar groups, it's also tracking the maximum power point of each solar group such that we gain as much energy from the sun as possible.
Yes, and this is because, of course, every joule of the sun that falls on our panels is one we want to capture. And the reason we're showing specifically this system, and we also brought it with us today, is that we saw a lack in the current technology over here. Because at the moment, if you want an MPPT for an electric vehicle, you need two conversion steps. First to a lower DC voltage, and then to your battery. We thought 2 conversion steps is very inefficient, so that's why we came up with the world's first 400-volt MPPT, which can directly go from your solar deck into your battery and your motors with an efficiency of even 97.2%.
Yes, and in the heart of this revolutionizing converter lays a LSC resonant converter, which enables zero voltage switching, and that results in a higher efficiency than other converter types. Besides, we used a lot of cutting edge and new technology, like the switches, that are GaN switches, new technology, but also the transformer core has a distributed air gap to minimize the losses in the converter, in the transformer. And also the rectifier diodes are made of silicon carbide diodes. That all result in a high efficiency of 97.2%. Besides, a lot of these components are select based on their performance. That's also why we use a lot of Japanese components, especially the capacitors. For example, output capacitors, but also one of the most important capacitors in our converter, which are the capacitors in the LC resonant tank. Because our solar groups are not even sizes, they have also a different output voltage. And that's why this converter needs to have a diverse voltage input. So we designed this MPPT such that the voltage input can vary from 40 to 100 volts to ensure that every solar group can be connected to the MPPT. The output voltages is also quite diverse because the battery voltage of our car varies in the state of charge. So the output voltage is about 260 to 400 volts and can easily be optimized to 600 or 800 volts by some small adjustment to the converter. Also, we designed this converter as this MPPT as a standalone unit, so that's easily integratable not only in our car but also in existing cars that are nowadays on the road. So that's quite important for us and other companies because that means that you can easily integrate solar cells not only in new vehicles but also in existing vehicles, which make the step to integration of solar panels more logical.
And in fact, one thing also to mention about this board, it has full safety integration already. So that's also why it's possible to integrate it into current vehicles, as it surpasses the isolation measurements that need to be taken in a high voltage system, but it can also, when it detects a too large input or output voltage, automatically shut itself off both through hardware and software. And that also galvanically isolates the solar panels from the rest of the system.
Yes, and this guarantees not only the safety of our battery, because you do not want to overcharge your battery, but also of the passenger.
So, to conclude and summarize, who are we? We are students from Eindhoven, from a last team, and every solar team characterizes itself by being a team of very enthusiastic and motivated students. What we are able to do is build new concepts, since we are partly free from industry. We do not need, we are a non-profit organization, so we can try new things that nobody else dares. But we are also industry in a sense, because many companies and startups have arisen from our team, but also we are in close collaboration with industry. Because if we want the newest technology in our vehicles, we need to have good partners. That's why we have partners like Siemens and NXP, but in fact we have more than 100 partners. And what does it mean to be a partner? For us that means that we can, for instance, use the new technology of a partner and then showcase to the rest of the world what it's capable of. Be a testing case. Those are all things we do, or even collaborative engineering.
Yes, so what's more, in September of 2024, the new solar team will start, and they're going to do the next challenge in sustainable mobility. So if you really like our concept or want to cooperate in that project, come to us. We were really honored that we can tell what a student team is and what we as Solar Team Eindhoven are doing. So, as Nick already said, we have a nice demonstration of the MPPT. You can see how it works. We can explain more if you're interested. So, thanks for listening.
Well, thanks, Nick and Niels. I found it a very inspiring story. Not only like just creating a solar car. No, you come up with new innovative concepts, you're building it yourself, you come with a new car, off-road car. So I think I speak also for the rest of the people in the audience that it's a very inspiring story. Let me ask you like a personal question. Once you finalize this project, you finished your studies, what are your plans starting a career? Do you think about automotive industry, or do you have different plans?
Yeah, for me, I really like the automotive world. So I'm going to do my internship next year. This should start next January, and I'm be honored to get a place at the Tesla headquarters. Wow. So that's a really nice opportunity, which I also get from the experience that I have here. So yeah, I really like the automotive field, and I think I want to stay in there during my remaining career.
Yeah, and for me, it can be more diverse. I'm not necessarily only fan of automotive. I'm a fan of high tech in a broader sense. So in 2 years, I will find out where I'll end up. Broad interests.
Yeah, we have the time for that. Well, thanks again.
Thank you.